Welcome to the Virto Commerce channel on YouTube. In this presentation, we'll inform you about the technical details we have changed in version 3 of our leading e-commerce platform. We will discuss the benefits of version 3 changes and what they mean for you as a customer or as an integration partner. We will also cover backward compatibility and which significant changes are introduced in version 3. Let's have a look at what are the primary objectives for the third version of the platform. The first idea of version 3 was a technological migration from .NET Framework to .NET Core. This was a primary objective to ensure that the platform product does not quickly become outdated and is still attractive to the technical audience in the long run. The migration to .NET Core brings cross-platforming support that will significantly extend the scope of hosting and better containerization support. With version 2 of the platform, we had some design issues that were difficult to fix due to backward compatibility reasons. Therefore, we consider this new major version an excellent opportunity to implement all architectural change objectives. And the last and important goal was to maintain the full backward compatibility with the second version for the REST APIs and provide the most straightforward process of updating from the second version. On this slide, you see all the key benefits we believe version 3 can bring. Version 3 has increased the total development productivity by up to 30%. This indicator is based on the results of our internal team, who worked on the same tasks for both versions. We linked this fact to changes in the architecture and other factors, such as the restart of platform performance. The second benefit is cross-platform support. We have successfully run version 3 on the Linux OS and on the Linux-based Docker containers. This means we can now host the platform on different cloud hosting services, such as Amazon Web Services. In version 3, we made many major architectural improvements. And we eliminated design issues, which led to tight coupling between modules and problems with updates and publishing releases. Now the modules are more in line with the autonomy and the shared nothing principles, which also lead to the creation of a more flexible configuration of the infrastructure. It is now close to the classical architecture of microservices, where you can run multiple platform instances with a limited set of installed modules, working with its own infrastructure. The platform's extensibility and the modules have been improved. We have added many new extension points. For example, the catalog domain model is now extendable. The most important benefit is that we are using cutting-edge and the latest technologies for our products. Take a look at this list. The latest platform version uses the ASP.NET Core 3.1, while F-Core 3.1 is still used as the primary ARM. The full version 3 of REST API is 99% backward compatible with version 2. Technically, we used special tools to compare Swagger OpenAPI docs for both versions and eliminated any differences we found. The link to the complete list of REST API and program code changes is on our docs on GitHub and in this video's description. We also recommended watching another video on our YouTube channel explicitly devoted to updating from version 2 to version 3. Find the link on that video in the description to this video. Thanks to preserving API backward compatibility, the storefront version works well with both platform version without any changes. Therefore, there is no need to change storefront code during the update. One of the essential architectural changes is that we got rid of the tightly coupled dependency to the core module. This was a serious design issue that led to redundant releases of core modules that conflicted with each other. Now in version 3, it is no longer necessary to release a new version of the core module each time you change domain models implemented in other modules. This change can simplify the process of receiving new updates. In version 3, we completely redesigned the logic of the cache usage. The caching module has been removed, and we redistributed the logic for caching to each module. Moreover, we have removed the third-party cache manager library for a memory cache, which has instead been introduced into ASP.NET Core. We also retained the possibility to synchronize local caches for different platform instances via Redis service. In version 2 of the platform, we used custom abstractions and implementation for membership and security tasks based on OWIN security, and we partially used ASP.NET Identity for membership. Since ASP.NET Core Identity is now supporting the role permissions claims, we can only continue to work with the standard features provided by ASP.NET Core. To enable token authentication, ASP.NET Core supports several options for using OAuth 2.0 and OpenID Connect. We use a good third-party library and OpenID to provide a simple and easy-to-use solution for implementing an OpenID Connect server in platform application. It is based on ASP.NET.Security.OpenID Connect.Server (ASOS) to control the OpenID Connect authentication flow and can be used with any membership stack, including ASP.NET Core Identity. Using the standard ASP.NET capabilities for security tasks makes it possible to better unify the product and reduce the learning curve threshold and the number of errors, as well as facilitate integration with third-party identity services. Because of the change to the security functionality, we have achieved the possibility to run the platform in authorization server mode and share the issued tokens between several instances, operating as a resource server. This significantly expands the possibilities for scaling, where we can run several instances of the platform as microservices with a single authorization center. The logic of notifications was completely reworked and moved out from the platform project to the new module. The new implementation has better support for extensions. This means the possibility to overwrite existing notifications, add the new individual templates for each store, and define the new sales channels. Because the tools previously used for bundling scripts and styles of the platform manager were deprecated, ASP.NET Core refuses the use of a built-in runtime bundler, and Bower Package Manager is no longer supported. As we had to find a replacement, we now use Webpack as de facto standard in the world of web development. This is the primary tool for bundling and processing your scripts and styles on the development of the platform modules. We have changed the folder structure for each platform and module solution. Now the folder structure is better organized and more close to the recommended best practices for .NET projects. All things such as documentation and samples are stored with source code. Thanks to that, we can keep all our documentation and samples into GitHub together with the source code for quick access. Here is one of the essential additions to version 3, the VC Build global tool for automation of the tasks related to building, packaging and publishing Virto Commerce modules. With cross-platform support, it can be easily integrated into the various build servers and continuous integration pipelines. We use these tools in our internal CI/CD processes running on the Jenkins build server and GitHub Actions. The last slide is a performance report that confirms outstanding improvements in load and indexing time for version 3 compared to version 2. That is all for this presentation, and any comments are welcome. Thank you for watching.